पार्शियल डेरिवेटिव और डिफरेंशियल क्वेश्चन और इंटीग्रल कैसे सॉल्व करते हैं हमने डिस्कस कर लिया था। आज हम लोग डिस्कस करेंगे कि इस लेक्चर में कि हाउ टू सॉल्व द लीनियर अलजेब्रा, उसको एक्सप्लोर करेंगे कैसे उस पर काम करता है। तो मान लीजिए आपके पास कोई एक लीनियर वेक्टर है। The linear vector u equal to vector 2 5 7 with 2 I cap plus 5 j cap plus 7 k cap. Then the particular place फिर ये आपका हो गया लीनियर वेक्टर। चेक करना है कि किस टाइप का है, टाइप क्लास सेज मॉडल वेक्टर इंटीजर डेंस वेक्टर इंटीजर डेंस नॉट में। अब देखिए अगर डिफाइन करना ओवर द वेक्टर, ओवर द इंटीजर, ओवर द रेशनल, over the reals, over the complex number, yeah, any finite fields, then one is equal to vector z over z. And the 2 1 comma 5 and the next u2 vector is q over q 1 0 5 and the u3 vector for the over real to real, then the 6 1 comma 7 and the u4 vector complex to complex 2 1 a and the GF in Z5 for the 2 comma 2 1 5 for the finite field. Then the represent U1 U2 and also the U3 for the real to real and the U4 the complex base of the finite field. Big finite field with this if 2 है 5 से division the remainder is 2 but the 1 is also remainder 1 आएगा. But 5 divided by 5, the remainder is 0, then value is 0. Over the coefficient over 5, the multiplication 5. Then plot the vector plot, U1 plot, U2 plot, or U3, U4, and the U5. Then a 5 vector, U1 vector for the Z over Z, and the U2 vector is the rational to rational, and the U3 vector is the real to real, and the U4 is the complex to complex, and U5 is the finite field with Z5. Then plot मैंने अलग अलग U1 vector के लिए रेड कलर लिया हुआ है और then line ये आपकी लाइन है कि उसमें जो U1 vector is the red part is the Z to Z, ठीक है, और आपका नेक्स्ट द ब्लू पार्ट इज द U2 vector and the next is the U3 vector is the green, the complex to complex, and the U4 is the maroon in that color is the complex to complex part, and the here after the rosy brown part is the finite field, and also telling the automatic field. See, any question? If the frame is false and the first if the frame is true, then frame of included. ठीक, तो ये आपका वेक्टर से रिप्रेजेंट कर सकते हैं फॉर द प्लॉटिंग, ठीक है, and also the vector operations such as the addition and the differentiation, determinant निकालना हो या another thing. The vector A defined is the 1 2 comma minus 4 and the vector B is 1 minus 1 1 and the C vector is 2 1 minus 1. After the same is the plotting in the previous discussion, तो ये आप इसको वैसे ही प्लॉट कर सकते हैं. It also included in the frame. ये आपका वेक्टर मिल जाएगा. क्लियर है. अब मान लीजिए सच द मल्टीप्लिकेशन स्केलर मल्टीप्लिकेशन पार्ट U2A plus 3B plus 4C, then U is evaluated, then value. ठीक है. नेक्स्ट थिंग अगर मान लीजिए आप यहाँ मैं एक सेल ऐड करता हूँ, ठीक है, ऐड इस मान लीजिए हमने इसी वेक्टर को a 5 into A and the plus 3 into B plus 2 into C, then evaluation. So scalar multiplication base the 5A, 2B, 3B and plus 2C is good. And some condition अगर आपके पास कोई वेक्टर है that is the U और या another vector is the A जो अपने ऊपर डिफाइन किया हुआ है, that is the norm, the A dot norm and also B dot norm and also C dot norm. One and for the another value is a C norm represented and also we conclusion the V is equal to and W is equal to and Z is equal to C naught. Then apply for the V, comma W, comma Z. Value. And the V is the A dot norm is the root 14 and the B dot norm is the 3 root under 11 is the for the vector V and the root 194 is the vector C. And also the U defined for the 5A plus 3B plus 2C is also norm is U dot norm value is the under root 3761. Clear है? This is the norm 1 definition, the normal function analysis. A dot norm 1 then value. Okay, U dot norm is value. And the norm 2 is nothing but a basic norm, is the Euclidean norm, such as the normal norm. The Euclidean norm. Next thing is the A dot norm is the infinite, is the supremum main is the norm. The A dot norm the value and the U dot norm. So I think such a part is clear condition and also uh, such as the U dot and the tag and apply for another thing. This is a coefficient call the conjugates and the cross product, curl, degree, denominator, derivative, and also the dot product. Apply for the leading coefficient choosing. Only choose the vector and dot and the tab. Okay, so that is and also the eigen tab of the infinite not and also the apply the dot product. What is the dot product? Vector A dot vector B is equal to magnitude of vector A and magnitude of vector B in the cos theta and the yeah basic Euclidean dot product the A dot B the component wise multiplication. The A vector is the 30, 40 and the 50 and the vector B is 15 and 12 and 50. सबसे पहले इधर show the vector clear. Then in the A dot product B, then only A dot or what is the dot product B. Then evaluation divide. And the another way the dot product is the only the star A star dot B. A star B is the also the same property for the dot product का evaluation. Value में कोई difference नहीं होगा. And then choosing the cross product. Cross product the A cross B is the I से cap and the A1, A2, A3 dot is define करते हैं. उसके बेस पर define कर सकते हैं the W in the cross product. And the W the term are defined as the W and the dot product of the A. This value is 0 यानी that vector W is a perpendicular to the vector A and the W vector dot product of B is also 0, then W is a perpendicular to vector B. Clear है? Next is the orthogonal projection. What's the meaning of the orthogonal projection? In a linear algebra, the orthogonal projection of a vector A and onto a vector A is a component of the vector B that lies in direction of A. This is also such as the formula for the projection of B onto A. The A comma B belongs to RL part, yeah, R3 part, R2 part, and the projection A, this is its index part, and the B. ठीक? Any orthogonal projection of B into the A, and such the in the direction of A, the projection A, B, the A dot B, any dot product of A into B, and the A dot A into the vector A. So A dot A is also the norm of A ka square, or also the using the matrix notation, and the A transpose it into B, and the A transpose into A into the A. In the next thing is the geometrical interpretation. The projection is the shadow of B onto the line spanned by the A, and it minimizes the distance between B and any point on the line through B. There's a A comma B, the evaluation, such a different one. So second is the orthogonal projection of A into B. So basic is the A dot product B upon B dot product B into the whole B. पूरे part में the dot product can define the value. And also the definition such as the Python using the part, yeah, basic definition used function type. And the definition is the orthogonal projection say v comma u. When orthogonal projection is v ka on the in the direction of u, the written definition v dot product u, u dot product u, yeah, story. And also same way define the another way in the definition of orthogonal projection is the j v comma u and the return v dot product u on a norm u chi square and the u because the u dot product u is the nothing but a norm of u का square. So same definition दोनों में से कोई एक define कर सकते हैं. Then the P is equal to orthogonal projection of say it is A comma B and defined by such as a definition के through is directly and I define the definition seriously. तो अब यहाँ vector change करके देखते हैं B comma B या तो ऊपर vector B और C define किया हुआ है तो आंसर and the B dot product the A minus P is nothing but 0 यानी वेक्टर A minus B को आपका उससे अगर हम वेक्टर A को माइनस करते हैं और B के साथ डॉट product निकालते हैं then value is also 0. The value is 2541 and then using the A comma B and then the values. Next thing is the scalar triple product. Then the scalar triple product of the three vectors A given by is the A dot product of the B vector cross C, the B cross C, and the geometric meaning of that vector is gives the scalar triple product. It gives the value of the parallel B beta formed by the vector A, B, and the C. As the result is 0, the vectors are the plane. If the scalar triple product value is 0, then that vector is co-plane. Determinant form is the A dot B consider scalar triple product A1 A2 A3 B1 B2 B3 in the serial situation. And then if you compute the scalar triple product in SageMath, scalar triple is equal to A dot product, okay, that's the definition. And the next B dot cross product the C. So the scalar value. Interpretation is the if the scalar triple product is 0, then the A, B, C are linearly dependent. If the not equal to 0, then the A, B, C are the linearly dependent. And the non-zero results give the signed value of the parallel between. The मैंने फिर से यहाँ तीन वेक्टर डिफाइन किया हुआ है वेक्टर A, B, C. Okay, then the define for the scalar triple product. And also change the value so to the 12, 23, and 31, and 42, 52, and 64, and 20, 29, 91. That's what we are defined. Such as A comma B comma C also. So, and the scalar triple product is the A dot product in definition, scalar triple product, and the A dot product, the B cross product C, then defined. Is it easily defined with the scalar triple product, and the also the vector triple product. The vector triple product is the also the vector product. The value is the also vector. After the simplification, such a vector the using the vector triple product definition in the A cross of B cross B C vectors, the vector content using the VAC CB rule, we simplify the also rule. The A cross B cross C in the A dot C and A dot product C of the B and the A dot B A dot product B and into the C. They compute the anything is a vector A B C and the vector triple product definition as CVC rule. Interpretation in the sense that result in a vector in the plane of the B and C and the orthogonal to the A. The identity shows that the result lies in the span of the B and C, not orthogonal like the scalar triple product. The same is the vector A, B, C are defined, and the vector triple product definition are applied. Then not magnitude part is the vector quantity. And the identity base in the define the BACB rule, then the A dot product C and the into the V and the A dot product V into the C, then value same. And also the plot for the parallelepiped the ABC in the any three vectors. The P equal to plot मैंने A vector का color दिया हुआ है red and the B vector color is the green and the C color is the blue and the line 3D defined for the plotting in the line 3D. The projection is the P जो आपने already define किया हुआ है. Is the parallelepiped part. Is the projection part is the P plus line 3D A comma A plus B and the B comma B A plus B and the also include A comma A plus C and the C A plus C B B plus C and the C B plus C and the also the A plus B or A plus B plus C A plus C and the A plus B plus C and the B plus C and the A plus B plus C. The R color as by choosing the black part and the return is the so the definition are used. P is the plotting for the P and the frame is the false and also included in the frames is the true the evaluation and the expert ratio is the automatic. Then firstly the definition apply and the next thing is the plot the parallelepiped is a evo defined part and that is the parallelepiped. Also the using the frame is true. Frame. आप इसको फ्रेम के अकॉर्डिंगली देख सकते हैं दैट इज द आपका parallelepiped and the defining the black part is the line 3D the P plus and the another is the vector A vector B vector C. Okay, and also the absolute value of the vector triple product is the value part is the parallelepiped that define the value. Okay, basic criteria is just such like the Python library. Same is the SageMath. The define the matrix in the question mark. Then matrix defined, argument in the QWS, then function defined. So this says the matrix one is the 2 plus 2 matrix 1 comma 2 3 comma 4 and the evaluation in the shift enter is the 1 2 or 3 4 and also the matrix identity the 2 यानी जो matrix आप define करें 2 plus 2 matrix is identity matrix such a defined way And also the many things defined in the matrix definitions. You can choose and read the data and use the SageMath the same. Okay, and the next is the matrix, the overview and the matrix defined. So our classification system, the 2 plus 3 matrix. What is the simple definition? The matrix 1, comma 2 and 3, comma 4 basic. मैंने फिर the 3 cross 3 matrix define किया हुआ है. In the A matrix 1 3 4 7 8 and the 9 8 10. In the 3 cross 3 matrix use super interface and the including the 3 dot characteristic polynomial. Such as direct implication that A dot with a characteristic polynomial. Then the x cubed minus 18x square minus 25x plus 25. Any question? And the A dot characteristic polynomial, the x cubed minus 18x square, x cubed minus 18x square minus 25x plus 22. And the A dot conjugate to the transpose, the A conjugate. Any question? Okay, A dot conjugate transpose. So, rational to rational, any complex conjugate polynomial is directly conjugate transpose into the transpose. So that value and also the eigenvalue are defined, A dot eigenvalue, and the eigenvector the left and the also the that is the A transpose is the same value. And determinant is also is and A defined to the A inverse and the norm extended electrical norm and the dimension in the column also defined. So मान लीजिए आपके पास the A vector and the dot and the tag such as the eight polynomial can be transformed is ring such about Cholesky the Hermitian matrix coefficient instances that about the module is the which basis is missing one requirement position argument one person then do not define about Cartesian product and also the to define for the V is equal to or so then the change the n. So with a square matrix, the M is not a square matrix. The 2 cross 3 the dimension the math error हो सकता है and also the that vector is the A dot null. So the A dot null is that and the extended expression from a dimension column defined and also the the reduced echelon form for the identity matrix. The matrix is different. And also define the system of linear equation. We consider a system of two form and the 2x plus 3y minus z equal to 5 and the 4x plus y plus 2z equal to 6. The minus 2x plus 5y plus 2z equal to minus 3. And the matrix of A dot be the x equal to vector B. Then the where A is equal to that, the matrix form is to convert the coefficient for A equal to 2, 3 minus 1 is 2, the x vector and the B vector. And also they define the matrix. There are two ways in the solve. For the A dot solve right B, the written vector the system is big solution. If A is the singular, the system move infinite many solution. And the A dot rank is check and the A dot augmented B the dot rank for the consistency check. So such as the other direct I'm define the matrix part and the B equal to vector and the dot, which is very direct. Then another thing is the basic idea is the variable x comma y comma z. Three variables x, y, z. Then solve what are you? 2x plus 3y minus z equal to 5 and the 4x plus y plus 2z equal to 6 and the minus 2x plus 5y plus 2z equal to minus 3 and define basically x, y, z direct. Yeah, basic matrix are defined. Change our matrix and the B vector are defined and using the x to the A dot solve right B. Now got to check the AX equal to B. Is this is true or not? I think here. Any question? Regarding किसी का कोई question?